Just make your list of what you need to know for your equations. And, so you have your two diagrams here. These equations are actually in your table, so they don't need to be learnt off. Okay, so here you go. Okay guys, make a list of, just draw your diagram at the start. Two smooth spheres of equal mass collide directly while moving velocities 2I and I. Collide directly, so it doesn't say they're travelling towards the other, does it? So it's just +2 and +1. So 2 and 1. You don't need to specify the I or the 1. Okay. After collision, they move in the same direction in the ratios of speeds 11:13. Now here's the problem, okay, with a ratio. A ratio could mean that's 11 and 13. Now that's not going to happen, is it? Because it was going 2 and 1 in the first place. So there's going to be, the 11 and 13 are going to be, it's going to be 11 parts of some number and 13 parts of some number. So we're going to use a letter K. So K is more than likely a fraction. And so it's almost like, if you did a ratio before, it's like 11/24 of some speed is this one here, and 11/24 of some, 13/24 of some speed is the other one. So you can do it using fractions, or you can do it using the letter K. Letter K stops you from having to introduce too many fractions to the equation. You could use both systems. You could use this system here, or you could use this system down here, whichever one comes to your mind at the time. Now we're just going to make a list. Phi1 being 11k, Phi2 being 13k, U1 being 2, U2 being 1, M1 being equal mass. So if they're equal mass, just call them M. Put them into, we'll start off with NEL. Okay, so when we start off with NEL, what we're going to have is Phi1 minus Phi2, which is going to be 11k minus 13k. U1 minus U2, it's going to be 2 minus 1, equals, does it say anything about the E value? Nothing about the E value, so I'll just got to keep it as minus A. Okay, cross multiply you up, we're going to get minus 2k equals minus E. E equals 2k. Right, so there's our first equation. Now we're going to do PCM. So I'll just reduce that there. So PCM now. M1, U1, so it's going to be M times 2 plus M times 1 equals M times 11k plus M times 13k. Therefore it's going to be, all the M's will cancel. 24k equals 3. As suspected, k is a fraction. K equals 1/8. And now that k equals 1/8, this means the velocity is what the velocity is going to be. Phi1 is 11k, which is 11/8, and Phi2 is 13k, which is 13/8. Finally, the E value is 2k, so 2 times 1/8, E value equals 1/4. What do you make of that question? So, in this scenario, we're going to have 2 collisions. Okay, so 1, 2, 3, and then second. So we're going to write down what's going on here. They all are a line, the rest is a straight line. A is propelled towards B, and the coefficient restitution between the spheres is 2/3. Find their speeds after one collision. Okay, So they're all at rest at the start, and A then gets thrown towards at 6. What's the likely scenario to happen here, guys? What are the scenarios that can happen? Scenarios that could happen is that A collides into B, B then collides into C. After that collision, it will be sufficiently slow to be caught up by A again. That's how you have to figure out how many collisions can actually take place. So it's very forensic. You just break down each collision on its own, and you always ignore the third particle. So for the first collision, we're going to have they're all equal. So M1 equals M2 equals M3, all equal to M. For the first collision, we're going to have a U1 and a U2, and a V1 and a V2. So we don't know what 6, 0, V1, V2, and then we're just going to use our formula. So just go for your formula. Okay, so we go for NEL first. NEL is going to be V1 minus V2, anybody? So it's just V1 minus V2 all over U1 minus U2, which is 6, equals minus 2/3. V1 minus V2 ends up to be minus 12 over 3, which is 4. PCM, okay, is this here. So PCM is going to be M times U1, so 6M plus 0, because it's not moving. M1 V1, which is MV1 plus MV2. V1 plus V2 ends up to be equal to 6. You happy enough with that? Okay. Sorry? Is it minus 4? Oh, yeah. 6 times minus 2 over 3 is minus 4. Okay. You're going to get 2V1 ends up to be 2, V1 ends up to be 1, and V2 ends up to be 5. Okay. Once you've done that, what you can do next is just you just can reset your diagram. So when you're resetting your diagram, A is currently going at 1, B is going at 5, C is going at 0, and you're going to do a separate equations to the one you just performed there. So after this collision, we're once again going to use V1. We can use V3 and V4 just to signify that it's a second collision, okay? So we're going to have V3 minus V4 all over U3, sorry, let's make a list. U3 equals 5, U4 equals 0, V3 equals I don't know, V4 equals I don't know. The masses M2 equals M3 equals M. Okay, V3 minus V4 all over 5 equals minus 2 over 3. Therefore, V3 minus V4 equals minus 10 over 3. 3V3 minus 3V4 ends up to be minus 10. You don't have to use V1, V2, V3, V4. You can choose letters if you want, if that gets too confusing. Any questions on that? Any else? So just put that in a box, and then PCM is going to be M times MU1, so it's going to be M times 5 plus M times 0, doesn't exist. M times V3, M times V4, all the M's cancel. V3 plus V4 equals 5. Multiply that by 3. 3V3 plus 3V4 equals 15. 3V3 minus 3V4 equals minus 10. 6 phi 3 ends up to be equal to, oh, this is interesting now, 5. Phi 3 ends up to be 5 over 6. What's the significance of 5 over 6? Sorry?
Less than velocity of the first.
So this is less than the 1 coming in behind it. So we're going to have a third collision, guaranteed. Okay? Now we're hoping that the C value has to be bigger than 5/6. Okay, it has to be bigger than 5/6. So we'll find out what phi 4 is. Phi 4 ends up to be 5 minus phi 3, using this equation over here. Phi 4 ends up to be 5, which is 30 over 6 minus 5 over 6 ends up to be 25 over 6. Safe to say that phi 4 is safe. C isn't going to be in any more collisions anytime soon. So that's your second collision, okay? You go back to your diagram to top and you realise next that it's going to be so C is going, what do we say, 25 over 6. C isn't going to be cut, so we just need a new data set. U1 equals 1, U2 equals 5/6. Phi, oh wait, we're technically on U5 and U6 now, aren't we? Because I already used them. U5, U6, phi 5, phi 6. And we don't know what they are yet. So we're just going to use all this data here. Okay. And then we're going to bring all this information down the bottom. And we're going to start again. So we don't know what these are, okay? So let's start off with NEL again. Newton's experimental law. Phi 1 minus phi 2, which is going to be phi 5 minus phi 6 over U1 minus U2. 1 minus 5/6 is basically just going to be a sixth. And then on the other side we have minus E. What's minus E again, guys? Minus 2/3. Bring up the sixth and multiply it. What do we get? Minus the ninth, because the 6 goes up there, so it's going to be phi 5 minus phi 6 is minus 1/9. That's going to be 9 phi 5 minus 9 phi 6 ends up to be minus 1. Okay, principle of conservation of momentum, PCM. So what we're going to get is m times 1 plus m times 5/6 equals m times phi 5 plus m times phi 6. The m's will cancel. Phi 5 plus phi 6 ends up to 1 plus 5 over 6, which is 11 over 6. Cross multiply 6 phi 5 plus 6 phi 6 ends up to be 11 over 6. Now they're not exactly the nicest numbers that have ever existed, but sorry? Just 11? Yeah, sorry. Multiply the top one by 2 and the bottom one by 3. 18 phi 5 minus 18 phi 6 ends up to be minus 2. 18 phi 5 plus 18 phi 6 ends up to be 33. 36 phi 5 ends up to be equal to 31. Phi 5 equals 31 over 36. Okay, now if I was doing this the second time, what I'd do is I'd just be really lazy about it and reuse what I already had, and I'll just come up here and change the signs. Minus, plus, plus. Then I'm going to get 36 phi 6 ends up to 35. Phi 6 equals 35 over 36. I now know guaranteed that no more collisions will take place. How do I know that? We got 31 over 36, 35 over 36, and 25 over 6, which means that nothing's going to catch up, so the three of them are just going to keep rolling on forever without any more collisions. Okay.